ui's and vj's. It is possible for us to find ui's and vj's. And that is what the next step, step number 3. Now, next one is step number 4. Step number 4 for non-basic cells. Okay, so I told you that this is a non-basic cell, this is a non-basic cell, this is a non-basic cell, because the value is not assigned here. This is non-basic cell, this is also a non-basic cell, and this is also a non-basic cell. Am I correct? For these non-basic cells, we have to find the so-called net values. Okay, net values we have to find for non-basic cells, net values for non-basic cells, by using this particular formula. Okay, this is the formula that you have to do to find the net values for non-basic cells. This is a formula. Okay, again I will take the problem, at the time you will understand how to calculate the net values here. Okay, how to find the net values I will explain you when the problems I will take there. Okay, so for non-basic cell net values, for basic cells fixed cost. So don't confuse. For basic cells we have to find fixed cost by using this particular formula. For non-basic cells we have to find the net values for by using this formula for non-basic cells. Okay, non-basic cells. Right. This is step number 4. Now, if you come to the step number 5, okay, we have to see all the net values. Okay, net value you will get for non-basic cells. Suppose there are 5 non-basic cells are there, then you will get the 5 non-basic cells. You will get 5 net values. For that 5 net values, if all are 0 or negative, okay, 0 or negative, then the optimum is reached. Our solution we got. So all the optimum, when we say that optimum, all net values must be 0 or negative. Okay. If all the net values are 0 or negative, then we have reached our solution. We can stop the problem and we can give the solution set and the total transportation cost. That's all. We cannot move further. That is the optimum transportation cost. That is minimum among minimum transportation cost. Okay. Suppose all the net values are not 0 or negative. What is the meaning? If any one of them is positive, what can we have to do? Well, we have to go further. Okay, we have by using this particular formula in the step number 4, we are calculating net values for non-basic cells. If all are 0, all are 0 or negative, all are 0 or negative, then the problem is over. The solution set you will get. Solution set means what? How many products can be transported from the corresponding production center to the corresponding destinations. Okay, that assignment procedure we call the solution set. Then if you multiply the number of transported item by the cost and add all of them, you will get the total transportation cost. Okay, so if all the net values are 0 or negative, then what we understand, the problem is over. That is the least transportation cost. We cannot find the transportation cost less than that. That is the meaning. Okay, so this is criteria for optimum. Suppose is the suppose because suppose is suppose because suppose is suppose is suppose. Okay, suppose if not means any one of them, I mean the optimum value is positive. If any one net value is positive or more than one net values are positive, then we have to go to the next step. That's very, very important step that you have to understand. Now we come to the step number 6. Step number 6. Okay, step number 6 we have to come for. We have to draw the loop starting from maximum positive net values. Okay, maximum positive net values. Okay, now look at the box here, yellow color box. The net value we will be the net values we will be writing here on the right top corner. So for non-basic cell, this is one net value, this is another net value, this is another net value, because non-basic cell, this is another net value, this is another net value, this is another net value. We will be finding out. Okay, so among these net values, which is the maximum positive? Okay, which is the maximum positive, that we have to find out. Maximum positive net values we have to identify. See the picture in the box. Suppose this is a maximum positive net value. From this we have to draw a loop like this, from here to here, then 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 we from here to here. Like that we have to draw the loops. Okay, so I will tell you later. I will tell you later about how to draw the loops. Certain rules are there. According to that particular rules, we have to draw. Um, we have to draw the loops. Okay. So what are the loops conditions there? Now look at this box, transportation box here. I tell you what are the rules of drawing loops. Okay. Uh, Suppose you are starting here. This is a maximum positive net value. You can go straight column wise or row wise. You should not cross it. Okay. You should not cross it. You can go row wise or column wise. You can go row wise or column wise. That is the first rule. You should not go like this. You should not cross the cells. Okay, right. That's the first condition. You can go clockwise or anti-clockwise. This is a clockwise, so you can go clockwise or anti-clockwise. Like this you can go. Take for example, from here to here you can go clockwise, and from here to here you go clockwise, then from here to here, then clockwise, then from here to here there is, suppose, anti-clockwise. This is what is this? This is what is called anti-clockwise. Am I correct? Anti-clockwise. So this is anti-clockwise you can go. Otherwise you can go for by clockwise. Okay, now look at that picture. Clockwise you can go. That means what? From here to here this way, then from here to here this way, from here to here this way, then you have to join where you start. So this is other condition. You can go clockwise or you can go anti-clockwise. Okay, right. And then other condition is that the corner points of the loop, suppose this is a loop, then the corner points, this is one corner point, this is another corner point, this is another corner point, and this is another corner point. So these corner points must be basic cells. Okay, corner points must be basic cells. That is other condition. Corner points must be basic cell. In this particular cell you must assign, and the assignment should be here, the assignment should be here, the assignment should be here. So all the corner points must be a basic cells, that is assigned cells. Such a way you have to draw the loop. Okay, then one more condition, where you are starting there you have to end. Suppose you are starting here, then your loop should end at the same place. So where you start you have to end. That is another condition. So many conditions here. The first condition is it has to go straight. It may be column wise or row wise. First condition. Second condition, you can go for clockwise or anti-clockwise. Second condition is over. Third condition, the corner points must be a basic cells. Corner points must be basic cells. That's the third condition. And fourth condition, where you start there you have to end. Where you start there you have to end. So these are some of the rules of drawing loop. So this comes in step number 6. Step number 6, we have to form a loop starting from maximum positive net values. This is very